in. Hi, how can I help you today?
I think there's something wrong with my son's vision. I've done some research and I think he may be colorblind.
Can you describe any symptoms he may be showing?
Well, he constantly uses the wrong colors for objects. He has a low attention span when coloring, and he has problems identifying certain colors. He also has a sensitivity to bright lights, and he always complains that his head and eyes hurt if looking at a certain array of colors. I've asked him about it and he denies that he has any problems, but I decided it was worth looking into.
Yes, it is definitely likely that he possesses a color vision deficiency. In these cases, those possessing this disorder also have an excellent sense of smell and night vision.
What exactly is color vision deficiency?
Color vision deficiency, or more commonly known as colorblindness, is a genetic disorder that causes someone to have trouble seeing red, green, or blue, or a mix of these colors. In some cases, some people may not see color at all.
Is it true that this deficiency is usually caused by faulty cones and sometimes by a fault in the pathway from the cone to the brain?
Yes, it certainly is. The gene which is responsible for the condition is carried on the X chromosome, and this is the reason why males are more affected than women. One genetic change in each cell can cause a condition. It is more likely in males because women have 2 X chromosomes, and a genetic change would have to occur in both chromosomes to cause the disorder.
How is my son's vision different from normal vision?
People with normal vision have what's called trichromacy, and are known as trichromats. Trichromacy is when all 3 types of light cones are used correctly in the eye.
I've done some research, and from what I found, there are multiple types of color vision deficiency. What exactly are they?
Well, there are 3 main types: anomalous trichromacy, dichromacy, and monochromacy. Anomalous trichromacy is when all 3 cones of a person's eye are being used to perceive light colors, with one cone working slightly out of alignment. There are 3 different types of anomalous trichromacy. There's protomanomaly, which is a reduced sensitivity to light. This condition occurs in 1 out of 100 men. There's deuteranomaly, which is reduced sensitivity to green light as well as the most common form of color vision deficiency. This condition occurs in 5 out of 100 men. Then there's tritanomaly, which is a reduced sensitivity to blue light and is extremely rare. Then there's dichromacy, which is when only 2 types of cones are able to perceive color, or in other words, they have a total absence of function of one cone type. This means that there is a specific section of the light spectrum which can't be perceived, and those suffering from dichromacy may have trouble seeing reds, greens, or blues. There are 3 different forms of dichromacy. First, there's protanopia. People with protanopia are more likely to confuse black with many shades of red, dark brown with dark green, dark orange, and dark red, some blues with some reds, purples, and dark pinks, and mid-greens and some oranges. Next, there's deuteranopia. People with deuteranopia are more likely to confuse mid-reds with mid-greens, blue-greens with gray and mid-pinks, bright greens with yellows, pale pinks with light gray, mid-reds with mid-brown, and light blues with lilac. Finally, there's tritanopia. People with tritanopia are more likely to confuse light blues with grays, dark purples with black, mid-greens with blues, and oranges with reds. Finally, the last type of color vision deficiency is monochromacy. People with monochromatic vision can see no color whatsoever, and their world consists of different shades of gray ranging from black to white. In other words, they live in a world of gray. Monochromacy is extremely rare, occurring only in 1 person in 33,000. Its symptoms can make life very difficult. Usually someone with monochromacy will need to wear dark glasses inside in normal light conditions. It's highly unlikely that your son possesses this form of color vision deficiency due to its rareness.
How can we tell what type my son has?
Colorblindness can be difficult to detect, particularly in children with inherited color vision deficiency, as they may be unaware that they have any problems with their color vision. Generally, you can go to your local optometrist to get tested for colorblindness, but in some cases you may have to pay extra. There are multiple tests that are easily accessible to your son that he can take, but the most popular is the Ishihara plate test. This can test for red or green color blindness, but not blue color blindness. It contains 38 plates of circles created by irregular colored dots in 2 or more colors. The plates will be put in front of you, and you will be asked what number you can see on the plate. Some plates contain information which people with normal vision can see, whilst others contain information that only people with color blindness can see. If you make a certain amount of errors, you will be diagnosed with color vision deficiency. There are also more professional tests that he can take to determine his condition. but it is likely that with a consultation at your local optometrist or by taking some tests online, you'll be able to determine his form of color vision deficiency.
Will this be an invasive procedure?
No, it will not. Because it is such a routine procedure that can be accessed from the internet, it will be no problem for your son to complete the testing and determine his color vision capabilities.
So if he tests positive for this disorder, will that mean that he does possess a color vision deficiency?
Yes, it will. Currently, there is no definitive treatment for this disorder. However, if he does test positive for color vision deficiency, the condition will likely have little effect on his day-to-day life.
What does living with color vision deficiency mean for my son?
Well, colorblind people can face many obstacles in simple everyday life activities, including gardening, sports, driving a car, preparing food, or selecting clothing.
Is there any way this condition could negatively affect his future?
There are some careers where it is accepted that colorblindness could cause safety concerns. These areas are transport services, armed forces, and other areas in which it is crucial to be able to differentiate all colors. Industry is also forced to account for all colorblind people in the workplace for safety reasons.
Is there any way this disorder could have been verified prenatally? Would it be possible to reduce the risk if me and my husband have kids in the future?
Because it is a disorder that affects one's vision, it is not possible to determine whether they possess color vision deficiency until after they are born.
Okay, so what's the likelihood of any of our other children possessing this disorder?
It depends on your family history with the disorder. It's likely that if there are other members in your family that possess it, such as your husband, your brother, or your father, that your other children will possess it as well.
Well, my mother and I have normal vision. My husband, my brother, and father, on the other hand, are both colorblind.
So it is most likely that you are a carrier of the trait. To be colorblind means that both X chromosomes must possess the color blindness trait, which makes it a recessive gene. It is likely that you are a carrier for the gene, possessing a heterozygous gene for color vision. Your husband, on the other hand, would have had a homozygous colorblind gene to be color vision deficient. If you were to cross your genes together, the likelihood of you having another child that is colorblind would be 50%.
Okay, I think that's all I need to know. I'll book an appointment to get him tested. Thank you for your help.
Alright, thanks for talking to me. I'll be sure to refer you to a good eye doctor. He'll be able to help you out. Take care.
Thank you. Bye. I can't.
Alright. Chatting to you.
All right.
Alright, well, it was nice chatting to you.
Just a moment.
I will kill you. You had it.
Sorry. It's so bad.
Okay.
This test. Suspicious.
There's pathomolamely. This could cause safety. Areas where it is definitely differentiate would have to occur in both chromosomes. Responsible for the which is responsible for. I'm gonna get you to leave this.
I can't. Good, and then it's like blank.
Okay. Yes, it certainly is.